start. It's fine. So it's going to be recorded and sent to everyone, also with the notebook to access the code base where you can fine tune your own models. So no need to ask that during the chat, during the session. And Yakov is going to be there to answer your questions on the chat as well. So if you have any questions during the webinar, you're most freely to write it in the chat, and Yakov will try to answer it as best as he could. So I heard a couple of words when I joined about Yakov explaining like why fine-tuning is a really important release by ChatGPT, how they made it really easily for us to fine-tune our own models, which is a ChatGPT 3.5. Previously to that, it was a bit harder and required a little bit of more work, and it was more complicated to do, but now we're going to go through the steps. So what is fine-tuning? In simplified words, let me just hide Yakov. Yeah. So fine-tuning is taking a pre-trained model or a general purpose-based model like GPT, and then transforming it or training it into a more specialized model for a specific use case. For example, ChatGPT is a fine-tuned model of GPT-3. So the ChatGPT is fine-tuned on the particular use case of conversations. So it was trained to be optimal at having a conversation, and it's not the same as GPT-3. And yeah, this is an example of fine-tuning a general model or pre-trained model. And what we're going to do today is we're going to define a use case and then fine-tune our ChatGPT model into our specific use case. So fine-tuning allows you to, first of all, achieve higher quality results than prompting, because prompting is limited. Because with a prompt, you always have like a context and a context window with a certain amount of tokens. And then when you send it, the model is going to take it into consideration. But when you actually fine-tune the model and you change the weights in the model, think of it this way. You're changing the model's personality. Think of the model as a human, a student. And when you fine-tune it, it's just like you're giving him actual knowledge and changing his personality, the way he thinks, the perspective of the way they approach problems or approach situations. That's how fine-tuning works. So it changes stuff from the inside rather than the surface level. And fine-tuning also allows us to train a model on a larger number of examples that could fit on a prompt. So with fine-tuning, as you know, like with pre-trained models, the GPT 3 and 4, they've been trained on billions of parameters. And with fine-tuning, we can actually train it on anywhere from one example to a million or a billion examples. But of course, that requires like work, or a lot of work and a lot of hours or time spent on preparing the data. And fine-tuning also allows us to save tokens due to shorter prompts. And this is also, let's take an example of, we have a customer support. We have a customer support division in our company, and we want to release a model to answer or replace our customer support agents with AI agents. Now, those AI agents, we could give them a prompt with instruction, a personality, and etc. And this prompt is done with prompt engineering, and this prompt is going to be a couple of lines of text. So it's going to be like 4 or 5 or 6 lines of text, depending on the prompt we're going to use. And instead of using that every time the AI agent interacts with the customer, so instead of saying like, okay, we give it, first of all, like prompt engineering basics. We give it an instruction. You are a customer support agent for Staplatz. The context is you're gonna answer members' customer questions and always reply in a polite way. And instructions is how we usually answer our questions in Staplatz, because each company has an identity or a tonality and a way to answer questions. And that all can be in the prompt. So this, we can just give it to the prompt, to the AI agent or AI chat, and it can answer our customers. But with fine tuning, we can fine-tune or train the model on our criteria, which I just said, the prompts we're going to use, we can train it on them. And then we can, after we get our fine-tuned model, we can just release it or deploy it. And then we could just give it a question from our customers and it will answer it the same way with our brand identity or corporate identity and the tonality and the same output format. We don't have to input the whole prompt again. So in this process, we're going to save a lot of tokens long-term. And that depends on the use case, of course. So you got to figure out the tokenomics or economics of the tokens, how much it costs, and is it viable to fine-tune your own model, or is it viable to just keep giving in prompts every time you talk to a model? Plus, you will get a faster response time because you're just given in a shorter prompt with less amount of tokens, which gonna really retrieve a faster response. So we can discuss common use cases for fine-tuning. So as we said, we can fine-tune a model for a specific style, tone, or format desired. We can change the output, how we want the output. Do we want the output to be in bullet points, or do we want it to be in 1, 2, and then headline 3, 4? It depends on how we want it, so that we can train the model to give us a specific output. Do we always need the output in JSON format? This is specifically important if you're a programmer or coder. And we can also use complex prompts that aren't followed accurately, because as many of you have tried, I don't know who tried, who not, but if you actually, sometimes when you give a complex prompt that is long prompt with a lot of instructions, a lot of requirements, the model won't follow it exactly, like won't follow it specifically and accordingly. Yeah, it just sometimes it misses a step or it does something wrong. And this we could avoid by fine-tuning our model. Then we have also a new task is challenging to specify using a prompt. So we can also give it, let's say we got, you are a story generator, and every time, okay, you have every person has a specific style or tone when they talk. And sometimes we can't describe that by writing a prompt. So what we could do is we just gather our training data, which is our texts, our writings. I can grab my LinkedIn posts, my tweets, my journal, my blog posts, whatever I want to train the model on. And the text has my style because I wrote it. And then from the text, we can generate a Q&A, question and answer examples, and train the model on it. So this way, the model is going to be trained on the actual tone and the style of my text. And this style we can't format with normal prompts. So this is also an advantage. Sometimes when a prompt is too complicated to explain, then fine-tuning comes in, because fine-tuning understands the structure of or the context of the sentence, the subject, or whatever we're talking about. So a lot of you asked or are interested maybe about retrieval augmented generation. So we have right now fine-tuning versus retrieval augmented generation. So we talked about fine-tuning and when do we do that, but sometimes we want to talk with our data. We want to talk to our knowledge, we want to talk to our database, our PDFs, our files. We want to talk about our stuff. And this we do with retrieval augmented generation, not with fine-tuning. So the difference is with retrieval augmented generation, we'll give, it's like a student doing an exam and has access to open book. This is the retrieval augmented generation. It is better to use when we're using an external knowledge or facts that keep on changing. And fine-tuning is more about the personality and identity, tonality, and to steer the model in a better way. So the retrieval augmented generation, short for RAG, is better at external knowledge, to read external knowledge, and to minimize hallucinations as well. Because with fine-tuning, we're changing the personality, but not the facts. So we're not affecting the facts because the model is trained on a large data set. So if you want to change the facts or affect the facts, you actually gotta upload a lot of data, like millions or billions, to actually affect the general data set. But with retrieval augmented generation, the RAGs, we can actually, our model will go into our documents and retrieve the actual text or data in our database. So as I said, external knowledge, we use retrieval augmented generation and fine-tuning, changing model behavior. That's when we use fine-tuning, minimizing hallucinations, RAGs, training data. Of course, on retrieval augmented generation, we can't train the data. We just provided an external connection, which will give the large language model access to our data. Also with RAGs, as we said, the data is dynamic. So when the data changes, if someone adds a new, for example, onboarding process in our onboarding docs or on our onboarding wiki, it's always gonna refer to it since the doc it's in sync with our large language model. So if the doc keeps updated, then our large language model is up to date with our knowledge management. So here we got also a couple of explanations showing you the different criteria between RAGs and fine-tuning. So the RAGs are, of course, faster than fine-tuning because we're giving it the knowledge, and it's not, it has a smaller search radius. The computational cost is lower in retrieval augmented generation, while by fine-tuning it is higher because there are costs for fine-tuning our model, and then there are costs for using the fine-tuned model. So usually using the fine-tuned model is going to be more expensive than using the normal base model, which is the ChatGPT 3 or GPT-4. And these stuff we discussed also previously, that the RAGs are good for leveraging existing knowledge and domain expertise, while fine-tuning is better for complex tasks and learning patterns. So pricing, as we discussed earlier. So here we got to see the model, the context, which is the amount of tokens they have. This means like the amount of text we can input in one time. So here at GPT-4, 8K tokens right now, and we got 32K. And the only model we can train right now with ChatGPT is the GPT 3.5 Turbo, because they only released this model. Soon they're gonna, by the end of this year, they're gonna release the fine-tuning for GPT-4, which is gonna be super crazy and powerful. Because if you trained your ChatGPT 3.5 model correctly or with high quality data, it could achieve higher benchmarks and specific tasks than GPT-4. So imagine fine-tuning GPT-4 for certain tasks, then it's gonna be way better. It's gonna unlock a new level of quality for your specific use case. And here we can see the different prices for inputs and outputs. Inputs is the message you send to the large language model. Output is the message you get back. So here in 3.5, the cost is 0.003 cents per 1,000 tokens for input, and the output is 4 cents. But as you can see with the fine-tuned model, it's 4 times more expensive. And here it's also like four times more expensive. And there is also cost for the training. So that's why I said before fine-tuning your model, just sit down with your own use case and calculate the economics of fine-tuning the model. Is it going to be worth it to fine-tune the model? Or is it going to be worth it to just keep inputting our prompts every time we talk to ChatGPT or a large language model? So now we're going to talk about different methods of training or fine-tuning our large ChatGPT. So the first method is referencing a character. We can tell it, as you know from prompt engineering techniques, you can give it an identity where you can tell me a story, but talk like a pirate. This is the input, and the output, you'll get it once upon a time. So this is a method where you can also train the data. So you'll give it input, of tell me a story, and the output will be in pirate. And once you train the model on it, next time you use the fine-tuned model, you can just tell me a story, and it will automatically use the pirate tone if you train it on that. So method 2. Here we got also tell me a story, but use these tone instructions. So this is an example also where we can use fine-tuning. So let's say we go to ChatGPT and we want ChatGPT to tell us a story using these tone instructions. And these tone instructions are, let's say, my tone instructions for telling a story. And instead of giving the whole prompt to ChatGPT, we can train it on inputs and outputs based on this data, and then just go ChatGPT, tell me a story. It will automatically take these values into consideration. So this is an example of saving prompts and calculating costs. So instead of sending all of this, you can just send it, tell me a story. And this is the same example, but with different examples and stories, is we can also fine tune instead of doing few shot prompting. So few shot prompting, for those of you who know, is a prompt engineering technique where we give the model a couple of examples for our answer. For example, our prompt is going to be write me tweets in the style of Bill Gates, and then we'll tell it, here are a few examples of how he talks. And here, the examples we give to the large language model are going to direct the large language model to a better answer. It's like showing them, giving the large language model a hint. So we're actually narrowing the output and making it more specific to our use case. And by few shot prompting, we can also give it multiple examples. And this has been proven on many papers to actually increase the output quality of a large language model, like by high percentages. So instead of giving multiple examples, we can train the model in the examples. And next time we can just ask it, write me tweets in the style of Bill Gates, and it will automatically consider the examples or the examples, it was trained on. Yeah, so fine-tuning methods that goes to this, for example, we have another example, is to match the tone of a podcast host. What we could do is we can grab a podcast, transcribe it. It has a lot of data, and this data is distinct and has a specific style, specific voice, and has a person's capability. And also with transcribing voice and training on the voice is better than written, because in the voice, like when I talk, I pause and I say or I say like, or it grabs my the personality or exactly the way I talk. But when I write, there's not going to be or like. And this way, if I transcribe the way I talk and then I train the model on it, then it's going to write. Next time I train it on it, then next time I'm going to ask it something, for example, tell me about entrepreneurship in the style of Akram. It will automatically take or consider the way I talk with the pauses and the style and the personality. So this is also a nice example to try. Yeah, here, this is also like the conversation between two hosts in a podcast where you could actually identify the personality more than written text. So now let's go to the actual fine-tuning, where we're gonna do it step by step. So the steps we're gonna do right now is choosing a task. So the multiple fine-tuning, as we said, can be used for multiple application or tasks. One of them is summarization, question answering, or text classification. And this example right now, today, we're gonna talk about customer support questions, which is gonna be the question answering use case. So what we're gonna do is we're gonna prepare our training data set. OpenAI recommends that we use between 50 and 100 training data sets or Q&A pairs to get an noticeable output difference between the normal model and the output model. And by the way, 50 to 100 is really low examples. So usually it's higher, the more examples you got, the more accurate or the more you're gonna affect the ChatGPT personality and tweak it in your own likings. Then we're going to choose a base model, which is ChatGPT 3.5. Then we're going to fine tune it and evaluate the model performance. Okay, so today we're going to do it in Google Colab. All right. So before we, or we can just start. So in Google Colab, so we got a Google Colab notebook right now where we can run our code on the cloud and use a GPU from Google Colab where we don't have to use our own laptop. So it doesn't matter what device you have, you can fine tune your model using Google Colab. So first thing you do, just, reconnect. Yeah, here's a step-by-step guide. So first step, as you said, like data generation. So we want to talk about generating data for customer support. And here, using this prompt will actually help us generate examples, because examples are going to be, examples or the training data for fine-tuning a model is going to have a certain format. The format is going to be, I can show you in a bit. So this is the format. It's the format where we train our data. So usually we have the message here. We got the role, the system. The system is our large language model. So usually this is where we give it, for example, act as a copywriter, or you are a world-class storyteller. This is where we give the large language model their identity. And then the user is our prompt. This is when we interact with the large language model. And the assistant is the large language model answering us. So this is the typical format for training a data set or training a large language model on a specific data set. So this format is in JSON format, and this is the required format to train our model. Of course, you can see it in OpenAI, fine-tuning ChatGPT. So on the OpenAI website, you can find a lot of helpful information that would help you. And here you can also see use cases where improves durability, reliable output formatting, as we discussed, and custom tones. And here it will show you the steps. So by prepare your data, here you can see an example how the format should be. And you should copy this example where we discussed we got the role of a system, the user, and assistant. And then we upload our files to OpenAI, where it's going to train the model on our files. And then we're going to create the fine-tuning job. And then we can use our fine-tuned model. So you don't need the code right now. This is just for people who are curious to read about it more. All the code you need is here. So if you go back to the top, here in this notebook, we are gonna generate our data set by using GPT-4. So usually if you wanna train a model for high quality data, you do the data per person. You get what OpenAI does, for example, when they train new models, is they hire professionals in a certain or specific field, and they use those professionals to help train the model, because the professional can rate the input and the output of the model. And this would give better, higher quality examples than using a ChatGPT model or a large language model to generate examples. So the optimal way would be human for now, but there's also different ways of training. And right now I'm gonna use GPT-4 because the quality of GPT-4 outcomes are better than 3.5. So I'm gonna use GPT-4 outcomes to train GPT 3.5. So here I gave it a prompt, and this prompt here is, for example, a model that takes in customer support questions and responds with a polite but funny, well-reasoned, step-by-step, thought-out response. And we adjust the temperature. The temperature is, you can say, the creativity of the model. When the temperature is 0, then the model won't hallucinate or it won't be creative. It would just be based on facts or 1-to-1. It won't diverse a lot. And if the temperature is 1, then it will be highly creative, and some people call that creativity hallucinations. And here we specify the number of examples we want to create, how many data Q&A pairs we want to create. This is our training data set. So this line of code will help us generate a data set based on our prompt. And here in the prompt, you can change whatever your use case is. So then we can run the next lines. I did it already because fine-tuning takes some time. For example, in our use case, it took 20 minutes in this use case to fine-tune the model. So I did it earlier today, so we don't waste a lot of time in the session fine-tuning the model. And here we click on it. You just click on play. It will automatically run the code. We install OpenAI libraries, and here we input our API key from OpenAI, and we have a code that would help us generate the example, and would also to make sure that our examples or our data set don't repeat. So they're going to be variable and different from each other. And here we are given it also a prompt where you can see the whole prompt in Canva. I uploaded this as well. So here we're given it a prompt where you are generating data, which will be used to train a machine learning model. You will be given a high-level description of the model we want to train. And from that, you will generate data samples, each with a prompt response pair. So here we just gave it an instruction of what are we going to do for it to generate the right prompts for us, or the right Q&A, which is the question and answer prompt response. And here we're defining the format for our training data set. It'll be like the prompt goes here, response goes here. And then only one response pair, prompt response pair should be generated per turn. For each turn, make the example slightly more complex than the last while ensuring diversity. So we don't have duplicate data or repeating Q&As. Make sure your examples are unique and diverse, yet high quality and complex enough to train a well-performing model. Here is the model we want to train. And then we input our model, which is going to be the ChatGPT 3.5. So this is the content here. So this is the system message. We're given the system to generate us customer support Q&A questions. And after you hit play, it will start generating. So I gave it 20 examples. Here it's gonna start generating the 20 examples and then input or output the examples for us. Here it outputted some customer support example questions. Here is the question. My internet connection is pretty slow recently. What can I do? And the response. As you can see, it responded the same way we prompted it to. It's like, oh no, a slow internet connection is like a snail delivering mail. Not fun. Here are a few steps you can try. Like 1, 2, 3, 4. So after we did that, we run our system message line of code, which generate the system message. And the system message is, as we inputted before, given a customer support question, you will generate a polite but funny and well-reasoned step-by-step response.
Sorry, I don't understand.
Oh, my Apple Watch always likes to join in when I give workshops. So next step. Next step is to put the examples on a data frame and turn them into a final pair of data sets. So this line of code will help us actually organize and set up the examples based on our format. So here we have a training example because this is the right format. And then it's just going to input the system message, which we generate earlier here, the user message, which is the question, and the response, which is the answer of our message here. So this way, this line of code or this block of code is going to help us format the data in the right format. And after we click play, we're gonna see there are 20 successful.
Message.
Okay, what's up with it? Let's see. Yeah. So after we click play, we see that there are 20 successful generated examples. And after we hit play, we can check on the left side. On the left side, it's going to create a folder with our training examples. We can click on it, download, just to check it. Can use okay, so here, as you can see, these are our data set for training the model, and this was all generated by GPT-4. So here, as you can see, first of all,
no, we don't see your
oh,
JSON file.
Okay, wait.
We just see your screen window of the Google Colab.
Okay.
Yes, now we see. Yes, now we see everything.
Perfect. Yeah. Now, after I open the file, this is a file in JSON format where we have our messages, and we got the role, the system, which is going to be given customer support question. You will generate a polite but funny word reason step-by-step response. And then we got the user, which is a couple of examples about questions users might ask, and the answer. And here's the answer. So we got here, as you can see on the left, we got the numbers. So we got 20 examples as we specified in the notebook. So these are our training examples. Once we got them, they're here, we upload them to OpenAI. And we click on play, where we're going to upload them to OpenAI, which using the same file. Now, the uploading step might take a couple of minutes to upload because of OpenAI servers. So just wait like 1 or 2 minutes, and then we can train the model. And we can train the model just with one line of code, which is the fine-tuning job, which is creating a fine-tuning job. And we put in the file ID, which refers to our training file and the model we want to train. So after we do that, we click on play. And after we click on play, we can, after a couple of minutes, we can run this line of code. So once you run this line of code, just this line makes sure, this helps us check if the fine-tuning job is running or not. And as you can see here at the beginning, it says the job has successfully completed because I did it earlier today. But when you first start, it says the job has just started or is about to start, and then it will show you, for example, 1 out of 100 or 1 out of X, depending on how much data you're using to train it. And then you could just hit on play every 5 minutes to check the progress of your fine-tuned model. And this depends on, of course, how many data you use to train the model. The bigger your data set, the longer it's going to take. But OpenAI sends you an email every time like you train a model or the training has been finished. OpenAI sends you an email, which is convenient because you don't have to check all the time. So after we do that, we go to the next step where we get our fine-tuned model name. And once we hit play, we will get this, and this is our fine-tuned model name. And we can actually test it out in Google Colab, or it is automatically in our OpenAI playground because we use our OpenAI account to train it. And here we can just use the normal API call from ChatGPT or OpenAI, where we do chat completion. The model name is using our own model name. The system message is already given depending on before. And here is a question. We could tell, like, I have a problem with my Wi-Fi, as you can see here. Oh, Wi-Fi problems, the modern way frustrations. It answered the same way we trained it to. So we can now evaluate and compare the data, which we can do in the OpenAI playground. So the OpenAI playground, you can find it on the OpenAI website for those of you who don't know. And then we can go to the chat model. And here, as you can see the fine-tuned model. This is our fine-tuned model where we could use here in the playground. So what we could do right now is actually test the answers or the output of our fine-tuned model versus the GPT 3.5 model. And in order to do that, we have to consider the same environments or requirements. So we're gonna take our system message, which is here. This is our system message. So this is our system message. We need it for the playground where we give it our system message. And our answer would be, or our question would be, I have, or we can say like, my Wi-Fi is not working, okay? And we're using right now the 3.5 turbo model. Can do submit. As you can see, it just gave us this answer. We can wait for it to finish. All right, and here it's, hi there, sorry to hear about your Wi-Fi issue. Don't worry, we'll get back. That's like a normal one. If we use our fine-tune model and then we input it again, as you can see, it was way faster because it was trained on it, and it took the personality or the tonality of how we trained the model on. And right now, we just trained it on 20 examples of data sets. We didn't train it on hundreds or thousands or hundreds of thousands of data, which is pretty good compared to like 20 data set inputs. And here it just gives us like certain instructions, and it used the tonality of our prompt. And let's try, for example, without the system message. Let's see if it also gets our example. Yeah, I think it needs to have system message because it's a chat, and it was the same system message it was trained on in the notebook. But this is actually pretty impressive for 20 lines of code, 20 data set examples, which were trained on. And yeah, so basically right now we can train it on your own use case. So here are some couple of steps I'd recommend is, first of all, define what is the use case of your fine tuning. What do you want to fine tune it for? And then see the tokenomics, the economics of the tokens and the price. How is it worth it or valuable for you to actually fine tune your model or not? And then you can start training your data set, which is the hard part. So training your data set is the hard part because the higher quality it have, the more impact it's going to have on your fine-tuned LLM and the fine-tuned output. Because if you got low quality data set, then you're actually gonna make your large fine-tuned model rank lower than the base model, which is GPT 3.5. So in order to improve it, you gotta make sure you got high quality inputs or high quality inputs and outputs for the data set. And you can either do that by using the help of ChatGPT, make sure to use GPT-4, and with human review as well, because don't just depend on ChatGPT to do that for you. You can use it to help you generate data set pairs, and then you could actually go and review the pair, review the data set, make sure it's high quality, and it's always in question-answer format. So if it's about the tonality, for example, it's about my tonality, the question is going to be, what do you think about Startplatz? And this is the question, which is the user input. And the assistant output is going to be my answer, because we're training it on my answer. It's the assistant's answer. So when I answer, for example, yeah, Startplatz is the biggest startup and AI hub in Germany, and it's a place for innovation and disruption. So this, for example, would be trained as my personality, and the model would use the assistant message to train on my voice or style or tonality. And if we want to use for writing blogs or posts, the question or the user input is going to be, for example, write me a blog post about SMEs. So just that. And the assistant output is going to be a blog post. We can actually give in the whole blog post in our training data, which of course is going to be more expensive because you're going to use more tokens, but we can actually do that. So it's going to train on actually writing the same type or, for example, content style or how we actually want our blog post rather than doing it by its own. An example is when you ask ChatGPT or whatever to write you a tweet. We can say here, for example, write me a tweet about startups and the style of Elon Musk. So when we do that, as you can see, it always adds hashtags by the end. So right now, if you use Twitter a lot, you can notice or you know that hashtags are not used that much, where people focus on other things because ChatGPT was trained on data before 2021. So for the 2021, hashtags were a thing. And here in every tweet, you can try it. Anytime you tell a tweet, it always has like a long length and the same hashtags. And right now, Twitter changed their whole algorithm with hashtags, long form content instead of threads and stuff. So you can actually train your model on writing Twitter format posts based on new input. So this is also a use case you can try. And yeah, this is basically it for today. We just did we just scratched the surface for now. And in the upcoming weeks, we're gonna do a specific workshop for fine-tuning your own model based on your own use case, which is of course gonna be here in Startplatz, and it's gonna be more than an hour long, where we can work together on training the data sets and actually gathering the data, training the data sets, and training the models for your own use case. We're gonna release that in the upcoming weeks. Other than that, yeah, it was thank you all for listening, and we can move on to the Q&A session. So Jakov, you got any questions of the chat?
Yet for now, the chat was very behaving. They didn't say anything. So I also asked already around if anyone has questions. Right now, like one of my question would be, do you have a number? How much did this cost now? Like train the model on 20 examples and get the outputs that we got now?
We can check. Okay, we go to here. We go to price. Oh wait, no, not pricing. Go back. I think it's manage account, billing, or usage limits, I think. Wait, where was it? Overview. Oh, wait, oh, usage. So it used $1.36 for training and talking to it. You can say around $1 because I've been playing around with it. Like you could say 80 cents to $1 for
just the training.
Yeah.
Yeah. And I think this is also important to see and to know that instead of creating your own model that would cost you thousands of euros,
of course,
here you have it for 80 cents at same results, I would say.
Yeah, right now, like no one's creating your own model. If you don't have like millions and millions of backup money, you don't create your own model. You can easily use a base model and fine tune that base model depending on your own use case. But right now, I don't see a lot of, I don't see fine tuning that much valuable, like compared to retrieval augmented generation. Because right now, retrieval augmented generation is really good, specifically when you want to talk to your own data, you want to use your facts or knowledge systems in your large language model. And I see like in retrieval augmented generation, it's way more valuable, but of course it's depending on your use case. Fine tuning is better if you have a lot of people using the same prompts. So if you want to eliminate repetition in big companies or a lot, for example, your marketing division that has 50 employees, they're all using the same prompts every time they're writing social media content.
Exactly.
And that might cost a lot on the long term. So it might be wise to fine tune the model on the brand identity or the voice or how do you actually write the social media posts. Then it would maybe cost less or but take also less time, because every time you got to type in the prompt and sometimes it's not be accurate as possible. But the best thing is to do is if you have a fine-tuned model and you use that fine-tuned model with retrieval augmented generation. So you got the best of both worlds together. And right now, this combination, the hybrid of both, is ranking the highest in output quality.
Yes. The other thing, you could try out this new model in the playground. What did it took to put the model into the playground? How did you do it?
It automatically goes into the playground because you're using your OpenAI key, and your OpenAI key is connected to your OpenAI account. So automatically, once you train the model and you upload it to OpenAI using the code in the notebook, it's automatically in the playground and you could use it there. And of course, the model, the fine-tuned model, is just for you. No one else can access your fine-tuned model. So it's yours only because it's connected to your account for now.
Yeah, and probably as with all the other things, you don't have a tracking, right? It's an API call, so they don't store this data for training purposes.
Of course, yeah. They don't train the model on it, but it's still stored in US servers because you're using OpenAI. But so yeah, you gotta take care of the normal data and Schutz stuff. And
we have here a question in the chat. Can you also use terabytes of own knowledge base in form of PDF uploads to fine tune an existing, in this case, 3.5?
Of course you can. So, but depending on the use case, if you have a lot of knowledge base, which is like factual knowledge, it's better to use the retrieval augmented generation because you don't have to train the model. So you're not spending a lot of money and you're only spending the same amount of money as talking to a normal large language model, just a little bit higher. So there is no training cost where you can ask a question for your large language model and it would retrieve the answer specifically from your knowledge base. We did like a couple of workshops here in Staplatz about it, where we created a whole talk with your own data systems. We did it with no code, low code, and with using hard code with large language model frameworks like LangChain. And we're also gonna be discussing this topic in our upcoming foundational week, which is going to be in October. And we got next week the AI Bootcamp, which is going to be a 2-day intensive workshops in Düsseldorf. Also going to talk about this. And in the foundational week, of course, where it's 1 week where you learn all the basics and the foundational knowledge about generative AI.
And do you have a tip how to process huge data, like, for example, a podcast script, to use it for training?
Yeah, that could be done in multiple ways. You could either use transcription apps or web apps where you could actually transcribe a platform. And after you transcribe the platform, you can transcribe the podcast. You can grab the file. You can go to code interpreter in GPT 4.5, which is now called advanced data analysis. You could give it the file and you could give it the instructions. For example, I am training, or I want to train a ChatGPT 3.5 model, and I am in the process of creating and curating the dataset. Here is a transcript of the podcast. Please help me organize the transcript into Q&A pairs in the following format. So the format is also, as we said, you find it in OpenAI website or in the notebook. The format is messages and then the system, the user, and the assistant. So once you give it the information, then code interpreter would automatically use the data or the transcript and create Q&A pairs, related Q&A pairs based on that data.
Okay. I hope that's answered it. Well.
So I think we got another question from.
Oh yeah, true.
Yilmaz. So he was asking to be safe from the GDPR data privacy side. Can such a knowledge base, retrieval augmented generation, be hosted locally using an open source LMM? Of course, yes. With the retrieval augmented generation, you can use open source models. So if you use an open source model, you host it on your own servers, and then you use an retrieval augmented generation process to talk to your knowledge base. It's only going to stay in your server, so it's a closed circle and it won't be stored anywhere else. Of course, this is always a solution. There's a lot of different solutions, different possibilities, but right now it's a gray box with using large language models and your data and all that. So, but this is definitely a solution. If anyone has a question, you can unmute and just shoot. No worries.
Can you hear me? Or should I come?
Yes.
Yeah,
yes,
I can hear you. Yeah.
So I want to ask if we can train ChatGPT in for scientific purposes, like if we have some research-based models, we give some data for research-based models, example models, and train it in such a way that if some user in the future wants to create such kind of models, and it can use it in its much better form way. So we can train.
Yes, of course, because from what I understood, you want to train it on scientific papers, so it can answer or create scientific papers in the scientific format. So it uses the same style and tonality, right?
Not exactly scientific papers, but actually a scientific research. So it's, for an example, if you want to create some kind of simulation models for our purposes, so we gave a lot of huge data for such model, example models, simulation models, and in future we want to create such models with using ChatGPT.
Of course, this is, as we discussed, is the few shot prompting, where you give your large language model a couple of examples to guide them in the right direction. Because if you just give it an input, a question, the output field is going to be so wide. So the model can, because it's statistic probabilities, so it might give you a different answer, but it's still related to you. But when you give it a couple of examples, you're just defining it more and more and more. So you're making the search area narrower. You're narrowing the search area to your actual desired output. And this is a perfect use case for fine-tuning, because you could fine-tune it on a lot of examples, and next time it could automatically understand that when you ask it to do a specific research.
Thank you so much.
Yeah, you're welcome. Any other questions? Anything unclear you want to ask, feel free to just shoot. Okay. Ben?
Please send the link of the Google Colab into the chat so people can try
I can send it right now.
Yeah, and then we also can create a link to it. I don't know.
Okay, just a second.
Excuse me, I have one more question.
Yes, please.
Yes, sure.
For this training purpose, like fine tuning, we have to buy a subscription also. We can use a free open base, and then just we have to pay for the fine tuning cost that you have explained.
The API.
Yes. Exactly. You don't need the GPT Plus or whatever. You just need credit card or other payment method into your OpenAI account, so you can access the API. And if you can access the API, you can use the Google Colab notebook to train your models, and then you can try it out in the playground.
But for visualization, we need Plus, right?
I'm sorry, I didn't understand that.
For visualization of models, we need the Plus user, right? He's talking about simulations and visualization. So we need a Plus user for visualizations, right? Because free version doesn't give the visualization results.
Yeah, it's a little bit, it's not loud enough. I think you need a Plus account. Yes, you need a Plus account and the
visualization
and the API. Yeah, and the API token, and then when you train, you must pay with the token, the prices we see in the presentation.
No, I mean, free user doesn't take the.
You couldn't fine tune the turbo model with when you are free user. You need a pro account. Yeah, you must pay for account. Yeah, I think.
So you don't need a pro account. You just need a payment method in your OpenAI account, so you can use the API.
Okay.
But you don't need a ChatGPT Plus or whatever. ChatGPT Plus, you only need if you want to use the code interpreter to make your data easier accessible to train it. But if you have already training data, you can use it as it is with the API, but you still need to pay, right? So it and you only can use 3.5 because only the 3.5 model is fine-tunable right now.
Thank you.
Yes, 4 is going to be available for fine-tuning in the upcoming months. So by the end of the year, by the end of the year. And I just shared in the chat 2 links with you. One link is for the notebook, where you can just follow the steps easily. And the other link is for the slides. So feel free to download them. And also we got another question that says, is there any differences between the use of ChatGPT by OpenAI and the same offered by Microsoft Azure? Actually, no, there's only one difference. One difference is that Microsoft Azure is hosted in Switzerland, I think. So it is GDPR compliant, and OpenAI servers are in the US. But they both use the same model because, of course, Microsoft has a partnership deal with OpenAI. So it's just the same model, but different servers. So there is no difference in regarding of the model use or the power of the model. Okay, any last questions also about like ChatGPT or large language models in general? Me and Yakov are happily to answer any questions. Okay, then I want to thank you all for joining. And of course, if you have other questions or you want to find out more about how you can integrate AI into your life, your business, some AI use cases, or building the foundations of generative AI, feel free to reach out. At Startplatz here, we offer a lot of events in-house in Cologne and Düsseldorf, and online as well. So feel free to reach out and follow us on LinkedIn. We have like a Startplatz AI Hub webpage or event page where we keep you guys updated, and we share also news about the latest generative AI news. So I want to thank you again for showing up. I hope you guys found the session or the webinar insightful and valuable. And yeah, I wish you all the best and hope to see you soon.
Thank you. Bye.
Thank you.